So now, already we started with what is general divide and conquer method. So these are the 3 steps. We divide the problem into sub-problems. Here sub-problem is it is same as original problem where input size is less than the given input. Now recursively solve these sub-problems. Next, if necessary, we combine the solutions of sub-problems to get solution to given problem. For example, if you consider this binary search, you tell me what is divide step in this algorithm? What is divide step? Which step is divide step?
First, calculate the mid QSR.
Here we have numbers, no, madam. Step 1, step 2, step 3, step 5. Which step is step number? You please tell me. That is subset. Which among these 5 steps, which step is divide step?
Step 4 and 5 divide the problem.
No, sir, that's not.
First,
correct.
calculate the 2, sir. 2 step.
Step 2, sir.
Step 2 is divide step. This is actually divide step. Q only decides no automatically. Okay, it divides the problem into sub-problems. It divides the problem into sub-problems, or to be more specific, if you want this comparison also, whether you consider or not. After this only automatically array is divided. No, array is divided. Is that correct?
Yes,
Is that
sir.
correct? So this is actually amount of work we are doing in divide step. This you can consider, even if you want, you can consider even this also. You can consider that also. Is that correct? Is that
Yes,
correct?
yes.
Now you tell me what is concord step?
Conquer step.
Which step
In
is
this
concord
case,
step?
conquer is not required. Directly we return the index, so it's constant 1.
No, which step is concord step? What are the sub-problems here? How many sub-problems we have here? How many sub-problems we have? How many sub-problems we have?
In the code, there are 2 sub-problems, but any one, either of is going to be executed.
That is,
So 1.
actually, here we have 2 sub-problems. This is one sub-problem. This is another sub-problem. 2 sub-problem. What is A value here? What is N value? Okay, I can consider it as R minus P plus 1 as N. What is, that means total number of elements given to us. If we have elements from P to R, how many elements are there in our array? If there are elements in indices P to R, how many elements are there in this array? Each index P to R 1 element. Total this value is R minus P plus 1. No? Let us say N is R minus P plus 1. N elements are given to us. Then what is T of N? What is T of N? How many sub-problems we are solving here?
Sub-problems.
How many sub-problems we are solving?
Any one.
Only one. We are dividing into 2 sub-problems. 2 sub-problems we are getting, but are we solving both? Only one. Solving only one. We get 2 sub-problems, but we solve only one sub-problem. Based on some condition, whether to solve which sub-problem, that we decide. That's all. Is that okay? Now you tell me what is conquer step here? Which step? That step number you please tell me. Which step is conquer step?
4 and 5, I think, sir.
Both are conquer steps. This and this both are conquer steps. Is there any combined step here? Is there any combined step in this algorithm? Is there any combined step?
Not there, sir.
Not there. That whatever be the solution to sub-problem, same thing is the solution to original problem. Correct now? Whatever answer we get for sub-problem, same thing is answer for original problem also. That means there is no explicit combining of subproblem solutions. That's why combined step, it is 0, no work, no combined step at all. Okay. If n is r minus p plus 1, what is the recurrence relation for this? How many subproblems we are solving? Only one. What is b value here? What is b value? What is b value? Subproblem size is, what is the size of subproblem here? What is size of subproblem?
R.
By 2, sir.
Huh?
2, sir.
B equal to approximately 2. Okay, no, exact minus 1, all those things we are not considering. Approximately, loosely speaking, it is 2. So that means what is our recurrence relation? T of n is A times T of n by B plus F of n. What is the amount of work we are doing in divide step and combine step? Divide and combine.
Constant.
Thank you, sir. It is constant. It is constant, no? So that's why what is recurrence relation for this? T of n equal to A times 1 times T of n by B, n by 2 plus some constant. Is that correct? This is when n greater than or equal to 2. Why? It is even n greater than or equal to 1. N greater than or equal to 1. Is that correct? This is general divide and conquer. This anyhow we know what is the solution to this order of growth. It is same as theta of log n. This we have already done. No? Now all of you remember merge sort or not? What happens in merge sort?
Divide the list.
If we are given an array of say n elements, starting index is p, ending index is r. In order to sort this array, what is that we do? We divide this into
Pass.
two almost equal size subarrays. What is the difference between size of each of these subarrays? At most
by 2.
one. At most one. For example, if there are 7 elements, one side will be 3, one side will be 4. Definitely it cannot be 2 and 5 elements, no? If there are 8 elements, it is one side 4, other side 4. If there are 9 elements, one side 4, one side 5. That means the difference between number of elements, sizes of subarrays is either 0 or 1. Correct, no? Always. Okay. So now what are sizes of subarrays? What are indices of subarrays? In order to divide, we divide in the middle. Middle means what? P plus R by 2, no? Halfway point.
Yes.
Halfway point. Sometimes we may not get P plus R by 2 as integer. For example, P equal to
Some floating
3
point will round up.
and R equal to 8. 3 plus 8 by 2 means
11 by 2. 11 by 2.
5.5 is not
5.5.
valid. No? So we should get some integer. Either you make it 6 or you make it 5. That you decide. So let us say we are going to take it like this. Midpoint is P plus R by 2. This we call it as a Q. Then what are our subarrays now? Once a Q is known, it is clear. P2 key is one subarray. Q plus 1, 2.
1 to R.
R is another subarray. Now recursively sort this subarray. Sort this subarray. Similarly, here also sort this subarray. Then we will get sorted order, no? A, P2, P2Q, but it is now sorted. Here also we'll get A, Q plus 1, 2 R, but it is also sorted. Something like this, say 10, 20, 30, 40. This side may be something like this. 25, 32, 32, 36, 38, something like this we have got. After that, what is that we need to do? Whether the result will be automatically in sorted order.
Combine the individual modules.
Here it is q plus 1 2 r. If I take a array a p2r, is it in sorted order? No. Then what is that we need to do? What is that we need to do? Take first element here and first element here. You take one new array, okay? You take that array indices, say b, p2r, p2r. First element here, first element you combine, okay, compare. Out of this, whichever is small, which is small, 10 is small. You copy that and go to next element. Now 20 and 25 compare, which is small, 20 is small. You copy that and go to next. Now 30 and 25 compare, which is small, 25 copy and go to next. Now 30 and 32, which is small, 30 you copy and go to next. Next 40 and 32, which is small, 32. Next, go to next. 36 and 40, which is small, 36. Go to next. 38, 40. 38 is small. Once one side all elements are completed, other side simply you can copy. No, is that okay? This is called merge. That is combine. Is that okay? Is that okay? So that's what we are doing. Divide the n element sequence to be sorted into two subsequences of n by 2 elements each. This is with assumption that always n by 2 is integer, where k is greater than or equal to 1. If we are given 8 elements, every time 4, 4, next to 2, 2, like that we get. If we are given 62, 30, 64, 32, 32, 16, 16, next 8, 8, 4, 4, 2, 2, 1, 1. Okay. When do we stop? When do we solve the problem directly without going for dividing it? If there is only one element, no, that itself is sorted order, no? If there is only one element, that itself is sorted order. How do we know that our array contains one element or more than one element? Our array is like this. Our array is like this. How do we know that whether it contains one element or more than one element? P is starting index, R is ending index. How do we know that it contains one element or more than one element?
So P equal to R, then one element, sir.
Thank you, brother. If P equal to R, only one element, no? If P is less than R, if P is less than R, greater than or equal to 2 elements, can we say? Is that correct? So now, if we are given array A P2R, A P2R, so they are checking P less than R. What does it mean? Whether it contains greater than or equal to 2 elements or not. They are ensuring. One element means we need not call this procedure. No, that is the meaning. Next, calculating Q value. Q is P plus R by 2. Next, array divided into two subarrays. P2Q. Again, recursively, we need to start. For that same algorithm we are calling, but indices P2Q only. Next, this subarray, Q plus 1 to R. Same thing we call. Once these two procedures are completed, we will get two sorted subarrays like this and this. What is that we need to do? We need to merge these two. This procedure we invoke. Is that okay? Is that okay? Is that okay? Now you tell me in this algorithm, what is divide step? What is divide step? Which step is divide step?
Step number 2.
2, sir.
Thank you, sir. This is divide step. Is there any doubt? Is there any doubt? Okay. Which is conquer step?
Merge is a conquer. That is 5th one. 5th step, sir.
Fifth step is no. Conquer step.
Third and fourth, sir.
Third and fourth, because conquer means it is same as original problem. No, this is also merge sort. Only input size is different. Input size is different. What are conquer steps here?
3 and 4.
3 and 4. These two are conquer steps. What is combined step?
Fifth one.
So this is combined step. Is there any doubt in this? Now you tell me, what is the amount of work we are spending in divide step? Assume that there are n elements. What is n? R minus p plus 1. How many elements this array contains? R minus p plus 1. No, that I call it as n. Number of elements is n. Okay. Let this is n is R minus p plus 1. What is the amount of work we are doing in divide step?
Constant.
Only this one operation we are performing, no? So it is divide step. It is constant work. That means we can write it as theta of 1 or the go of 1. Is that okay? Now tell me, if there are n is also of the form 2 power k, where k is greater than or equal to 1. Now tell me, what is the amount of work we are doing in step 3? If n is of the form 2 power k. What is the amount of work we are doing in step 3? This entire algorithm amount of work is, when n is input size, amount of work I consider it as T of n. This entire algorithm, the amount of work is T of n. Now you tell me, what is the amount of work?
T of n by 2.
Correct. No, this is nothing but sorting this array. This is given as input. We need to sort it. How many elements are there? T of n by 2 elements. That's why T of n by 2. What is the time for the fourth step? Conquer means it is
Same,
request
sir.
to step. Automatically, the answer will be T in terms of T only. No,
Same, sir. T of n by 2 only.
T of n by 2. Now tell me, what is the amount of work we do in combined step?
T of n.
What is the amount of work we do in case of combined step?
N.
Why n, sir?
The finally two sorted partitions are there and we are going to merge it.
Here n
So-
by 2 elements.
Plus n by 2.
This side n by 2 elements. Can we say exact number? What is that we are comparing? What is our most important operation in this algorithm? What is most important operation? What is most important operation?
Combined step.
Merge.
Merging. That is fifth
What
one.
is most important operation? Okay, in this whatever 5 steps I have shown, it is this is most important. That's what we are saying. But our operations, no, whatever basic operation we take, they are not function
Comparison.
calls. What is the actual operation we are doing in merge? Inside merge, what is the operation we are doing?
Comparison, sir.
Every time one element from one sorted subarray and one element from other sorted subarray we are comparing, no? That is our most important step, no? That is our
Yes.
most important step. That means that is comparison. Or simply all sorting and searching algorithms, basic operation is comparison. Okay? All sorting and searching algorithms, basic operation is comparison. Okay. So 10. So now how many comparisons are required? If first subarray contains n by 2 elements and the second subarray contains n by 2 elements in sorted order, to combine this. This is sorted, but contains n by 2. How many comparisons are required? The answer is always same. You can take, okay, 2 instances. One side 10, 20, 30, and 40 also you can take. Other side 50, 60, 70, 80. This is one case. This is one case. This is case 1. Case 2 you can consider. One side 10, 20, 30, 40. Other side 15, 25, 35, 45. Whether both instances, both sorted subarrays, they require same number of comparisons.
First one,
Madam?
first one is already in sorted order.
Both are in sorted order.
N by 2 comparison.
Second one is more number of comparisons are required, sir.
First one, okay. So first one, how many comparisons are required, and second one, how many comparisons are required?
First one 4.
Yes, madam. Here it is 4.
Second one 8 comparisons.
8 or 7, depending on how what are you counting.
7. Okay, sir.
7 or 8, okay, no. Element comparisons is only 7. 7 is sufficient. 8 is not even required. Okay. So that means out of these two pairs, which pair is more efficiently merged? That means with less number of comparisons, it is merged.
First one.
First one, no? First one.
Yes.
Now you tell me, in merge procedure, number of comparisons performed, is it same always? No, it's not same. That means what does it mean? Even if I tell you that in both cases input size is 8 only.
8 only.
But
here
input size is 8. That means it not only depends on input size, but also actual values in the input or not. But actual values in the input or not.
Yes.
That means we should go for best case, worst case, average case, all those things. No. Now you tell me, in the best case, how many comparisons we perform here?
N by 2.
Thank you, sir. N by 2. In the worst case?
N minus 1.
N minus 1. But what is the order of growth here?
Same, sir.
Best case, N. Here also order of growth, it is also N.
Same.
That's why in textbooks also they don't explicitly talk about best case and worst case in case of merge sort. No, have you observed?
Yes, sir. Yes.
What is the reason? Does it mean that there are no best, worst, and average cases in merge sort algorithm? They are there, but asymptotically they are same. That's why people don't even talk about that.
Okay.
Are you getting?
Yes, sir.
Best case number of comparisons is N by 2. Worst case number of comparisons is N minus 1. But both have same order of growth. Okay. Best case order of growth is same as worst case order of growth, means automatically average case also it is like that only, no? So that's why there is no point in talking explicitly about worst case, best case, and average case in case of merge sort. That's why in textbooks also they don't mention that. Don't even mention that. Now you tell me what is the total time it takes, whether we go into best case or worst case. What is the total time it takes? We can say that it is theta of n. Theta of n. Is that correct?
Yes, sir.
So now finally, what is the reconciliation? What is general divide and conquer reconciliation in this case?
2Tn by 2 plus theta of n.
So T of n is here some constant work. Constant plus T of n by 2 plus T of n by 2 plus theta of n. So T of n can be written as 2 times T of n by 2 plus theta of n plus theta of 1 is theta of n only, no? Plus theta of n. Or some people they write this as T of n is 2 times T of n by 2 plus n minus 1. Some people even they write it as T of n is 2 times T of n by 2 plus n minus 1. However they write, whether all are same or not, all are same or not. Okay, not n minus 1. This is one is n, one is n minus 1. Okay, in textbooks, all the different textbooks, no different things will be there, no, like this. Is that correct? All are correct reconciliations or not?
Correct, sir.
Under the all these are correct under the assumption that n is 2 power k. Otherwise, all these are not correct. No, none among this is correct. Under the assumption that number of elements is always 2 power something, it is of that form. Is that okay? Now, which case of master theorem is applicable? Which case of master theorem is applicable?
Case 2.
By
Second
case 2, what is time?
N log n.
N log n, sir.
Log n by case 2. If you don't remember master theorem, okay, then can you apply recursion tree method? T of n becomes T of n by 2, T of n by 2, top it is middle n. Next it becomes like this, you will be able to get.
Yes, sir.
Yes. Based on that also tree height will be log n. So overall work will be n log n. Like that also we can do no if you forget no what is master theorem and all. By using master theorem cases also they got by applying recursion tree method only, no. So now instead of bothering about master theorem, we are also applying recursion tree method to our reconciliation and automatically getting the same answer. Is that okay? So here also it is finally theta of n log n. In all cases it is n log n. And is it a comparison based sorting algorithm? What does comparison based sorting algorithm mean? Which sorts the element by comparing one element with some other element of the array. Bubble sort, is it a comparison based sorting algorithm? Is it comparison based or not?
Sir, comparison based.
Selection sort? Comparison based. Insertion sort? Comparison based. Merge sort? This is also comparison based. Okay, but if any algorithm is a sorting algorithm is comparison based algorithm, then it has been shown that that algorithm takes at least n log n time. If an algorithm is comparison based sorting algorithm, it has been shown that it takes at least n log n amount of time. No comparison sorting algorithm exists which takes less than n log n time. That means because it is a comparison based sorting algorithm, only n log n is the minimum time. Merge sort is taking only n log n even in the worst case, any case. Okay, hence this is asymptotically the best algorithm or not? Asymptotically the best algorithm or not? Best comparison based sorting algorithm or not? Asymptotically, that point is important. Okay. Is that okay? If the array is almost in sorted order, which sorting algorithm among the sorting algorithms we discussed we use? Almost sorted order.
Insertion sort.
A few elements are out of order or something like that.
Insertion sort.
Insertion sort is best. Why? Because in that case, insertion sort, it goes into best case. In the best case, it is only theta of n, no? Insertion sort. That's what we proved, no? We discussed, no? So then it becomes same as best case of insertion sort. Okay. And in that case, it is theta of n only. Theta of n only. So for example, a bank is maintaining account numbers of account holders of that branch, but unfortunately what happened? No, so some numbers for example, yesterday's whatever transactions happened, those account numbers order might have changed due to some reasons. They have so many account holders, out of that few account holders, say maybe 50 or 100 account holders names have been okay, no, they are not in sorted order. Okay, no, they are not satisfying that condition. They are, okay, no, they are misplaced or mispositioned or whatever we call out of order. They are not out of order. Now only these records, if we want to sort it with this condition, if we want to sort the entire array, which sorting algorithm is better?
Sorry, sir.
Okay, I will make it simple. There are say n account holders of a branch, okay, no branch. Out of that, say K, C, where C is a constant. C account holders account numbers, they are not in the order. They are not in the order. They always maintain sorted order of account numbers. Okay, no? But only C, where C is some constant, 20, 30, 40, 50, something like that. Their account numbers are not in the proper order, but all other numbers are in order. Then which sorting algorithm is better to sort?
Insertion sort, sir. Insertion sort. No, we just
In this
discussed.
case also insertion sort is better. Why? Because this again goes into best case of insertion sort. That's why if you apply that, it is theta of n. Even if you apply merge sort, it will go into n log n, even in the best case also. Okay. So that's what we discussed for best case means not only element is present in first position like linear search. Even if it is present in second position, is it the same as best case? Yes, no. Even if it is present in third position, still it is same as best case. Still it is same as best case. Similarly, insertion sort, not only all elements are in sorted order, but also if they are okay, no, 2 positions away or 1 position away, still that can be considered, that is considered as best case. That we call it as almost sorted array. If the array is almost sorted, then still insertion sort is best to sort that. Okay. Now this is
Subarity, sir.
Madam.
Comparison algorithms are only these three, sir. Bubble sort, insertion sort, and merge sort.
No, heap sort is also that, quick sort is also that.
Okay.
All are comparison basis sorting algorithms only, no.
Okay, sir.
Except that only a bucket sort, counting sort, they are different. Linear time, okay. Here, what is running time of this merge procedure? Usually, can you say that if n is r minus p plus 1, can you say that what is the time it takes? Any step you take, what is time it takes? Can we say that it is theta of n? Okay, this anyhow you give it a try. Okay. We will have break now for half an hour. 6:35 again. We will resume the session. Okay, thank you.